So here is number 11 from Summer Review 7, and it was f of x equals x cubed minus 1 over x squared minus 9, so I just wrote it as y equals. And let's see, first of all, we can factor it right in its factored form. So I don't really need to factor the top because that's not going to, nothing's going to, I did it kind of in my head and nothing's going to cancel, but on the bottom I'm going to need that for the vertical asymptotes, x plus 3 times x minus 3. That's going to kind of help me there with the vertical asymptotes. Okay, and we first of all try to find some zeros, and if I just substitute 0 in for x, I get 1 over 9. And then if I put 0 in for y, or what's going to make y be equal to 0, anything that will make the top 0 but not the bottom. And if I put 1 in here, I'm going to have 1 minus 1. That'll be fine. And the bottom won't be 0. So those are a couple points, so I can put those on. When x is 0, y is 1/9, so it's a little bit over there. And then when x is 1, y is 0, and that's right in between because I'm using this particular scale. I don't know how much those 2 points will help me, but they're there. And this one's pretty close to 0. Probably closer than that. Okay, let's check for asymptotes. The degree of the top is greater than the degree of the bottom, so I have no horizontal asymptotes. I do have some vertical asymptotes, values that make the denominator 0, that don't divide out. So I've got a vertical asymptotes at x equals -3 and that x equals 3. And notice that the degree of the top is 1, exactly 1 greater than the degree of the bottom. So I do have a slant asymptote, and that's going to be found by dividing the bottom into the top and looking at the quotient without the remainder. And I did this over here just to save time, because I only have about 14 minutes at tops on these videos, and some of these problems take that long. Okay, x squared minus 9. It goes into x cubed x times, so I've got minus x cubed minus 9x, and I bring that down, and this degree of this is smaller than that, so this is my remainder. So I got 9x minus 1 all over x squared minus 9 is the remainder, but I'm going to omit that anyway, so I just have y equals this, or y equals x. So there's my slant asymptote. So that's how you find that, just long division. So y equals x. All right, so we'll graph that first. It's going right through the origin. Put a couple points here so I can. And that should go right through the origin if I. There we go. So there's your slant asymptote. Okay, no problem. Then we got a couple of vertical asymptotes at -3, so that's going to be between -2 and 4. And +3, that's going to be between 2 and 4. And try to get it right in the middle there as much as you can. That should work. So it's important to get these things right, and then you got some choices to make. Now the symmetry really helps us, but we don't have any symmetry about these. This is not going to be odd because we've got a binomial term. So if I put a -x in there, it's going to be different, and if I put this would be the same, but that's going to make the thing different. So none of our rules for odd or even functions are going to apply, so we don't have that going. So now we just have to figure out what's happening with our asymptotes. So we could either be down here or up here, and it could go like this, and it can even cross the asymptote, so we don't know. It could go up like this, or like, well, it could probably go through like that. So there's all kinds of things that can happen. So we're going to have to check these out by looking at behavior around the asymptote. So let's start with a -3. So let's see, as x approaches -3 from the left. All right, so I'll look at this, and this will be y equals And I could put negative 3 in the top, and that's going to be okay. And that's going to be, if I look at the top, if I put negative 3 in there, negative 3, it's going to be a negative cube, would be a negative, and then I don't have this in fraction form, that's a little odd. Okay, so I'm going to have negative 3 times 3 is 9 times 3 is 27, minus 1 in the top. And in the bottom, I can't put negative 3 in there, but I can put it in there. So I have x plus 3. I got to leave that, because if I put negative 3 in there, I'm going to get 0. Okay? But I can put negative 3 in there, and I'll get negative 9. I'm sorry, negative 6, negative 3, and negative 3 is negative 6, pardon me. So if I look at this, I have negative 28 all over negative 6 times x plus 3. Now I'm mostly just worried about my SIGN when we go this very small approach. So that's going to be a positive. So that's y equals a positive. And that's, you know, you can write it down. You could reduce it, so it would be 14 over 3. But it doesn't really matter because this is going to be the main thing. X plus 3. This would be the main deal. Now, as I approach it from the left, I'm going to y equals, and you could even call this 1 because it's not going to affect an infinity. So as I approach negative 3 from the left, I'm just going to be very, you know, just to the right. It's going to be negative 3.00001. Okay, that means it's going to be just a little bit bigger, so a little bit more than negative 3. And then I'm going to add 3 to that. And that's going to end up being y equals, and then 14 over 3 does. Like I said, that's insignificant. And this is going to be the main idea, 1 over. And since this is bigger than this, I'm going to have negative 0.000. I put an extra 0 in here, I guess this one doesn't matter, 1. And it looks like I've got a negative. So my side is going to be negative. And I'm dividing 1 by a very, very, very small number, so I'm going to have negative infinity. And then times 14 over 3 is still going to be negative infinity. So that's the way I say this doesn't really matter. So it's going to be down like this. Not up here. That would be like this. But it's going to be down here, so it looks like I'm going to go like this. And we don't know exactly how close this is going to be. So we could try a checkpoint if you want. You could try, if you want to, you could try like -4 or -5 maybe and see what's happening. But we're just going to sketch it out. So we're going to say it looks something like that. Okay? All right, let's try what's happening over here so we don't know what's going on over here. So let's try as x approaches -3 from the positive direction. So I'm approaching -3 from this direction. So I'm going to use what I did over here. Y equals 14 over 3 times 1 over. Now if I'm approaching it from this direction, it's going to be not quite, so it's going to be -2 point. Plus 3. So that's going to be y is going to be equal to, and then this is just going to be positive because this is bigger than the 2.99, so I'm going to have 14 over 3. And that's going to be 1 over positive 0.00001, something like that. And that's going to be, looks like that's going to be positive infinity. So it looks like I'm starting up here. Now we have to see what's going to happen when I approach 3. So go put it back in the original up here. So as x approaches +3 from the left, the negative direction. See what happens over here. All right. So when we put that in, y equals, if I put this in, if I put +3, it's going to be 27 minus 1 all over And then I can put positive 3 in here, so that's going to be 3 plus 3. And then the x minus 3 we can't do because that's going to be the 0, okay? All right. And that's y is going to be equal to, that's going to be 26 over 6, but the sign will be positive now, and then times 1 over x minus 3, or the same thing as 14/3. So we have y equals, 14/3. But again, that's insignificant relative to the infinity. And then times 1 over. Now as I approach positive 3 from the negative direction, that's going to be like 2.999. So what am I going to have? Y equals, it's going to be still 14/3. Excuse me here so you can see that. That's going to be 1 over, and since this is going to be larger, negative is larger, 3 is larger than 2.999, I'm going to have negative 0.0001, I guess. One up zeros here. Maybe I had an extra 0 over there. Okay, doesn't matter either way. You're going to have a very large number because it's very small, so it's going to be negative infinity. So that means I'm down here. And you can kind of... So what's happened is this going to come down over here. It's going to hit this 1/9, and then it's going to cross at 1, and then it's going to come down. Now we didn't know it could have gone up because it's asymmetrical, and it could have gone like this. So we don't know, so we have to check the behavior around the asymptotes. So that's why this very small approach is pretty nice. Okay, and then one more, we just have to see what's happening over here. Are we going to be like this or like this? So let's just check and see. Again, we can use this over here. So y, so this is as x approaches positive 3 from the positive direction, so y equals 14 over 3. And then times, and I can use this over here, 1 over, and then x is going to be from the positive direction, so it'll be 3.1001 minus 3, and that's going to be equal to, like I said, that's not necessary, and 1 over, and this is larger than that, so it's going to be positive 0.0001, and that's going to be approaching infinity. So we're up at the top, so we're going to look like this. So that's what we got. Okay, so let's check it with the calculator real quick. Getting close to my 14 minutes here. Put this thing on. Y equals, so this is what we've got, and I've got my function in there, and I've got my asymptote, so let's graph it. And there's this branch here, good. There's this little squiggle down here, there's the upper branch, and there's the asymptote. So there you go. So we nailed it. Okay, so I hope that makes sense.